Hello, everyone. A very good evening to all of you. Let's quickly begin with the session and see what all topics we would be covering in today's 90 minutes. So let me quickly share my screen. So just give me a yes or no in the chat if everyone can hear me properly, if even of you can hear me properly. Perfect. Thank you, Harun. Thank you, Ahmed. Thank you, everyone. Let's proceed ahead. I'll quickly share my screen. So is my screen visible to everyone?
Yes.
Perfect. So the topic that we would be covering today is under section 1. The first section is Internet and World Wide Web. And in this, our first major subsection is understanding Internet. So what all topics we would be covering under understanding Internet? Uh, Let me pull up my whiteboard and I'll show you quickly. Okay. So uh, a very quick overview. We covered very briefly what Internet and World Wide Web is while going through the curriculum walkthrough. So the first subsection is understanding Internet. In this, we would be covering three major topics. What is network? How Internet network is set up across the globe, and how we as developers can use Internet. So let's begin with our very first topic, that is what is a network. Okay, so we must have heard many times this is network, something other is network, and so much more. So according to me, what a network is simply a group of devices. I would say a group of devices connected together, and those devices are able to share information, can share resources with each other, and so much more. Let's see with an example. Let's see, suppose we have two devices, device A and device B. These two devices are connected through this cable. We can understand this connection. And now the resource or information is being shared. So we need to remember few major key points while referring to a network. Number one, this should be a group of devices. A network can only be formed within group of devices. Number two, the devices must be connected. This connection I'm referring to, this connection is very important. This one, this wire is very important. Number three, those devices are capable to share information, to share resources with each other. So three major points while considering a network. Number one, it must be group of devices, must be connected together, and can share information. And these three things, if are possible, we can create a network. Now, to create a network, we must have number of basic components. In order to achieve these things, these three things, we need some basic components of a network. We are going to cover those components today. Let's see. There are majorly four basic components of any network. So number one is network devices. As these are computers, computer A, computer B, these are network devices. Number two, it would be network media. The third component will be your network interface. And the fourth component is your network protocol. These four components together create a successful network. Do not worry, we would be covering each one of these today in great detail. What is a network? We understood group of devices connected together and can share information and resources with each other. What are basic components of a network? There are four basic components: devices, your media, interface, and protocol. And how these components are collectively working to form a network, let's see that. Let's move on to our first component, that is network devices. When we talk about network devices, we usually refer to group of computers, right? So whenever we talk of network devices, the first image come to our mind is group of computers. That's right. Computer is a network device. As we saw in the previous slide, that two computers were connected together. right? Now, along with computers, there are several other items that in our daily life we are using, and those are part of the global network. What those devices can be? These devices can be servers. You have servers; those are connected to the network. They are capable of sharing information. So remember three things: group of devices. Are they connected? Are they capable of sharing information or resources? So servers are capable. We also have gaming consoles or printers. Let's say printers. So printers are able to share information or provide resources whenever we want to print something. Nowadays, we can wirelessly print something, or using a wire, we can print something. So we are connecting it to a network. So in our home network, what are the number of devices connected? A computer and a printer together, they form a network between each other. They're able to share information with each other. Then gaming consoles are today, we are sharing information wirelessly, getting data and playing on PS4s. We are connecting it to our, let's say, LCDs or TV screens and so much more. Your mobile phones is a type of network device. There's some other amazing network devices that we're using that are making our life so much easier, like Amazon Echo. This is making the life of a normal everyday life so much easier, so much easy for everyone. Automated devices are there. So what are these devices called in technical world? In our web developer world, we call these devices as nodes and hosts. Remember this term. Most of the time when you enter the technical field, you would hear connect your host or connect your node. The nodes or hosts are these network devices. So network devices are not only computers, this can be any device which is connected and capable to share or receive information. And what do we call them? We call them host or node. So if I have to put it in simple words, a node or host is any device that is part of connected network and can send, receive, or forward information. So major 3 points. Any device, part of connected network, can send, receive, or forward information. So this is the first component. This is the first component of network. Moving on to the second component. The second component was network media. So let me clear my whiteboard and let me write network media. Now, network devices, we know what network devices are. Now they must be connected to each other in some way, right? In order to form a network, three conditions were: group of devices, first condition, group of devices, second condition, connected together. Now, how they are connected together, that is the network media. So network media. So the connection can be in any form. You have seen these connections in your daily life. It can be copper wire, through copper wire, or twisted cable. We call it a twisted pair cable. For example, this could be a LAN wire that you use to connect to internet, to your routers. So this is copper wire connection. The connection can be possible through electrical signals. Connection can be possible through fiber optics. Nowadays, fiber optics is heavily in use because they are fast. They are the the transmission, the data loss is very less in fiber optics. Then the connection can be through light pulses also. What are light pulses? Light pulses are flashes of light used to send signals through lasers. When we're transmitting data through lasers and light pulses, it comes under this category. When you're using your lasers and flashes of light, then we use light pulses. Or the most common that we are using network media today is the wireless connection using radio waves. The wireless connection, you're connecting your mobile phone to your Wi-Fi. It is a wireless connection. The media, the medium is radio waves. So the cables or signals that are used to connect host to network are referred as network media or medium in technical language. So in earlier slide, we saw the devices are called hosts. The media is called medium. The network media is called medium. In our web world, we call it as medium. How are you connecting your host? What is your medium? So what is network media? It can be any cable or any signal that is used to connect your host to the network. We are trying to achieve three conditions. Remember, group of devices connected together and can share information. So group of devices, we are connecting them in our network through network media. So this was the second component. Moving on to the third component. The third component is network interface. Understand network interface very carefully because it might be trickier to understand at first. So now we've seen there are different types of network media, right? And for different types of network media, the network host, the device, must be equipped with an appropriate interface in order to make the connection. So our device must be capable to get connected through copper wire. Our device must be capable to get connected through fiber optics. So for instance, if you take a very old printer, suppose a printer that was early 2000, that printer was not capable to get connected through your wireless connection. Remember, that printer was not capable because that printer was not having the appropriate interface that can use wireless connection or radio waves to get connected in the entire network. That printer could be connected through copper wire. We were using wires to connect our PC to that particular old printer. So what is an interface? Just remember, interface is a kind of device that enables the host to be connected with network media. Let me give you an example. Okay. I'll just pull up few good examples for us. Allow me just a moment. So everyone is able to hear me clearly, right? Just give me a yes in the chat. And everyone able to see my screen, right? Okay, perfect. So let's move ahead and understand what network interface is. So you have seen this network interface in your daily life as well. Every day you're using it. Let me show you an example. So in some cases, a network interface is an integrated part of your computer. What I'm talking about, let me show you. So suppose this is your network host. We have a PC and we want to connect it through into the network. So what it would require? It would require some media, right? It would require the network media, either copper wire or radio waves or anything to be connected. Now, how we can connect that copper wire to the host? I'm just taking one network media example. If we take copper wire or your LAN cable, how we can connect to that host, that is solved through network interface. So for instance, there is a network adapter in your computer. Just check this out. You must have seen this integrated network adapter. This LAN port, we say it LAN port, enter your LAN cable into the port. So this is an integrated part of your motherboard or network host. So this is often the case when connection with a copper-based media or twisted pair cable, for example, your LAN wire you're using. So let me show you this. It would be better to understand. This is your LAN wire. Now this is your media. Now this is your host, your device. This part is your interface. This is your interface. This is how a network is being built. This is your interface, right? So this is a very simple example that we are connecting through copper wire, through twisted pair cables or LAN wire. So sometimes these days, like we discussed, there are fiber optics as well. When we are connecting to different kind of media, for example, fiber optics, then most likely the engineer or you can say the owner of the host needs to install additional network adapter or fiber optic card to provide suitable connection. For instance, look at this. So you need to add on additional device to make it possible for your device to be able to connect this host into the with the network. Let me pull up the pin. Yeah. So this is a simple fiber optic port. Right now, our host is not capable to be connected to this particular of interface. In order to make it capable, engineers need to install additional network adapter. You must have seen, suppose you're using an iPhone, and in iPhone you do not have Type C. There are so many converters coming, that USB to Type C converters. Why these converters are there? These converters are there to make sure that your host is now capable to receive the data through the appropriate media. So if we use a fiber optic cable, if we use this particular fiber optic cable under this interface, it is not possible, because this interface is not capable to receive or send information to fiber optics. This interface was built to provide data to a copper wire. So we need to make sure what kind of media we are using and what kind of interface we are having. Interface is the connection between host and media. So let's understand the function of network interface. So let's see the basic functions of network interface, how this interface is working. So there are three basic steps. The first step is let's assume we have a computer over here. Let me explain it very simple way. Let's assume this is a computer, and the computer wants to send some data to a particular other device. So computer will generate some digital signals. What are digital signals? Digital signals are nothing but information generated in form of bits, ones and zeros. That is the language of computer. Computer does not understand English, right? So if we write a simple word like hello, so computer will convert that hello into a series of ones and zeros. That is the language of computer. So computer will convert these information into digital signals. Now, what is the role of interface? The interface, remember what I'm talking about. Interface is this adapter, or this fiber optic adapter. These fiber optics adapter or your integrated network adapter, these are interface. So interface will catch these digital signals. Interface will catch the digital signals from the host or network device and convert these digital signals into suitable signals, for example, electrical signals. And now these signals are to be transmitted through network media. So just understand this process. Okay. Just understand the process. First, digital signals, this is our interface. This is our interface. Remember, this is, I'll mark it as I. I means interface over here, or I'll write it over here. This is our interface. Now, interface is catching the signals generated by the host. This is host. And this is our network media. Now, interface is catching the signals from the host, transmitting into the appropriate type of signals so that it could be transmitted through the media that is attached to a particular interface. So over here we have copper wire, and our interface is integrated adapter. So that's why the interface is converting digital signals into electrical signals. So for instance, you're using radio waves, you're transmitting some data in wirelessly. Then your mobile phones, mobile phone A and B mobile phone, both have interfaces that can catch the radio waves and can send the radio waves as well. So this is the function of network interface. This is the third major component. Any doubts in interface, like just a quick doubts, anything you want me to explain again? So in short, if I have to say what is an interface? Interface is the middleman between host and network media. And what is the main function? It catches the signals from the host, converts into the required format, which is appropriately transferred through media. So this is a network interface, a very simple definition. So let's move ahead to our fourth major component. This fourth major component is very important. Fourth major component is network protocol. So what is a protocol in general? If we just refer to this one, what is a protocol? So if I define a protocol in English language, I would say these are agreed set of rules. Just focus on these words, agreed set of rules on how information is formatted and sent onto the network. So let me write it. Agreed set of rules, how information is formatted and sent onto the network. So what is a protocol? Protocol is agreed set of rules. These are set of rules. These are standardized rules. We cannot change it. We cannot alter it at our will. These are already set. They have been standardized and they have been accepted globally by all the companies and all the agencies that are part of the network. And what they are doing, what these rules are doing, these rules are telling us how information should be formatted and how that should be sent onto the network. If we explain it in a simple way, suppose you're trying to speak to someone who doesn't speak your language. For instance, you're trying to speak to a Japanese guy and he doesn't understand your language. You both are not on the same platform. You both are not on the same stage. Then a Japanese guy would not be able to understand what you are saying, and you would not be able to understand what Japanese guy is saying. So let me show you a picture. So let's consider this. This guy, for instance, says speaks French. This guy speaks English. Now both of them can't understand each other. Why? Because they are not on the same stage. And if we uh, if we say it in technical terms, they both are not following the same rules. If they're following the rules of a one language, one particular language, in supposedly English language or French language, then they both would have been able to understand. So in technical terms, in network world, the devices follow same set of rules. That's why they are able to receive information and they are able to send information as well. So let's consider following example. It would be easier to understand. Number one, let's say we have 4 different operating systems. Okay, allow me just one moment. I think we have a question on the chat. So Safi is asking that in network interface, you showed the LAN cable. How about wireless? Which one can we name the interface? So regarding wireless, Safi, I'm not sure about the name of the interface right now, because I'm just giving you an idea how network is working. So for instance, for LAN cables, we have integrated adapters. For interface, for wireless interface, we can Google it, and there must be number of interfaces. It is not the one interface. Even for LAN cables, there are endless number of interfaces. So we can Google it and see which particular interface is working in terms of radio waves. What my agenda with these sessions are to make you understand how things are working that we are using on our daily life. So one of the examples easier to understand was through network cable, through the twisted pair cable. So I can Google that and I can or we all can Google that and see which particular interface is used in particularly in wireless connections. So right now I'm not sure of the name right now. So I'll definitely research and tell you about it. Thank you. Okay, let's move on to the session. Okay, let's see. We were going through the network protocol, right? So let's consider a following example. Let me just pull up few good example for us. Allow me just one moment, guys. Okay. Cool. So let's consider we have 4 computers over here, right? Now these 4 computers are having different operating systems. So let's say computer first is having Windows 10, Then this is having Linux, this is having Mac and some Sun microsystems as well. So here, the communication is only possible as long as computers are configured to follow same rules, same protocols. Like we can see here, the communication is being transferred from one computer to the other. This is our host. Just say this is our host. This is our media. Let's say this is our interface. The interface is connecting the cable with the media. We have an interface over here, we have an interface over here, and so on. So how information is transferred from one computer to the another? That is only possible as long as computers are configured to use same protocol. Let's understand this with by considering two computers at one point of time. Instead of four, we'll consider two computers. So let's see that. So let's assume we have two computers, one with Windows 10, other with Sun Microsystems, and this is a network media. This could be your cable, this could be a wireless connection, this could be your electrical signals, and so on. And this is the data. This is the data. Do not worry about what these different layers are, because this is beyond the scope of this particular course. The application layer, presentation layer, these are different layers. So we need not worry about that. Let's assume this is the data. So now what is happening over here? So the protocol, the set of rules, what are they doing? The set of rules first assembles the data into the right format. It dictates how data needs to be assembled. So let me clear the screen. Yeah. So what does protocol is doing over here? The protocol is dictating how the data is assembled, this particular part. The set of rules format our data into the right I would say structure, into right structure that can be transferred through the network media. Now, once the protocol structures the data into right format, the second step is that particular data travels through our medium. Now, here protocol is doing nothing. The protocol has done its job first. It has structured the data first into the right format. Now, that right format is capable enough to transfer through the medium. Now, what's happening? The assembled data travels to the network medium. And the third step, at the receiving end, remember, this is the receiver and this is our sender. So I would name it as sender, and I would just mark it as R, indicating this is our receiver, right? I'll mark it as R, receiver. Now, the third step, what protocol is doing, the protocol also dictates how the data is unpacked, how the data will be received at the end, and when it is received by the another computer on the same network. So just see this. What's happening over here? We have sent, let's say we have typed a message. That message now turns into correct structure as per the set rules. There are certain rules how the message needs to be sent. That message is converted as per the set rules. After the conversion, the message travels to the network medium, and once it reaches the receiver's end, the message is again unpacked so that we as users can read it, can see it. If it's an image, we can see it. If it's a text, we can read it. So this is the role of protocol. The protocol in simple language is just set of rules which dictates how data needs to be assembled, how data will be unpacked. So two major things: assembling and unpacking. And if these happen as per the set rules, the data travels very easily through our network medium. So these were the four major protocols. Let's quickly summarize all four components of network that we studied so far. So let's summarize this. What are network devices? So network devices are nodes or hosts. We'll simply remember what are network devices. Network devices are nodes or hosts. It could be your computer, it could be your server, it could be your printer, and so on. So many network devices, anything that can be connected. What is network media? any cable, any wireless media that connects the devices together. So any cable, any wireless media that can connect network devices, that can connect the host. I'm using right now network devices because it's easier to understand, but mostly what we would be hearing when we enter the web world, that cables or media that connect your host, that connect your nodes. So remember, what is network media? Any cable, your LAN cable, your electric cable, your light pulses or wireless network, anything that connects network devices. Moving on to network interface. So now network interface has two jobs. First job is to connect the host to network medium, right? It is the middleman between network device and network media. Second job is to translate digital signals into signals that can be transmitted through media. So two jobs. Number one, used to connect host or network media. Number one, we are connecting this host with media with the help of network interface. Second job is to translate digital signals into signals that can be transmitted through medium. These signals into what category of signals, this is decided by what type of media we are using. If we are using twisted pair cable, the signals would be electrical signals, and so on. If we are using interface that is used in wireless media, the signals would be radio waves. So accordingly, the interface translates digital signals into signals that can be transmitted through media. And last, what is network protocol? Network protocol are simply set of rules used by hosts to communicate. Remember, set of rules used by hosts. The host is using those rules to communicate with each other. Set of rules used by hosts to communicate. So very simple, four components of network. These are used to create a network between group of devices. So this was the first part, the first part of our lecture today. What is a network? We have understood what is a network so far. Let's move on to the second part. The second part is, what is the internet? In normal life, let me clear my screen. I'll just show you. What is internet? So in normal life, we use the word internet to mean going online, right? Whenever we say we are online, it means we're using internet. Let me tell you, internet is nothing more than a basic computer network. The computer network that we saw how to establish using four components, internet is nothing more than that. Or we can say internet is a network of computers that span the whole world. Let me show you an image. So internet, we can say internet is network of computers, many computers connected together globally is called internet. So now if we dive a little bit into detail, if we see a bit deeper into this concept, and with all the topics that we have learned today, it is a network of lots and lots of not just computers, but hosts. Remember what host is. Host is any device that can be connected. And we saw under network devices that it can be more than just computer. It can be a printer, it can be a camera, it can be a smartwatch, it can be a phone, it can be a microwave, it can be a refrigerator, it can be your any server as well. So if we just dive a little bit deeper, network of lots and lots of hosts or nodes connected to each other is called internet. So you can see various examples, your microphone over here, printer, camera, your earphones, even your simple grinders. We have smart bulbs as well. We have air conditioners as well. You can see smart bulbs, computers. These are all a part of global network. And when they are connected, this is called internet. There's further more depth to this concept. If we dig a little bit more deeper, we find internet as, I would say, global system of many small networks. Just pay attention. Global system across the globe, connection of many small networks which are interconnected with each other through electronic or wireless media. So, for example, this internet, what is another definition of internet? Small networks connected to each other. This is your enterprise network. Suppose a small company is using an enterprise network for themselves. This is your home network, which is connecting your laptops, your mobile phones through a router, through modems, and so much more devices. This is a mobile network. We are connecting our cars to mobile phone. We can see the data of our car on mobile phone. For instance, you can check tire pressure monitoring system. You can check if your car AC has been on for more than 10 minutes. If your car has crossed the specified speed limit, if your car has breached the geosecurity radius that you have set on the application. How is that possible? How is data being transferred from car to your device? You can exactly check the GPS location of your car. This is possible through a mobile network. When these small networks, a mobile network, home network, and so many other more types of networks are connected together through one way or the other, like this network is connected over here, this network is connected over here. Just see this connections. So this is also called internet. So if we define internet now, we have plenty of definitions. Number one, group of computers connected globally. Number two, not just computers, more than computers. We have many devices that can be connected globally. And number three, small networks when are connected to form a large network, that is also called internet. So internet users can share variety of information and communicate with each other across the world. And that is possible only because of these particular networks that we have created. So we are able to share information at a split second. Huge terabytes of information is being shared every day. How is this possible? It is only possible because a very refined network structure has been established. And to establish a refined structure, we have studied these four major components of network, right? So now a question might come that how is this happening across the globe? How is okay? I'm just checking if we have any questions. Okay, no questions so far. Okay, so we guys will tackle the questions at the end. Once we complete the lecture for today, we'll tackle the questions at the end. We'll keep a good slot for the questions at the end. Don't worry. So now the major question that comes to our mind. Okay, we understand what internet is. How that it is a group of connected devices, group of small networks. But how is this connection being happening? Let me just okay. Right. So how these connections between the computers are happening, all these connections that we are seeing, how is this happening? How are we able to set up a huge global network? We understood a small network, right? But to get a huge global network, how is it possible? Let's see that. So question is how huge network is set up across the globe. Small network, we know we can use small cables and so on. But how across the globe? A very, very big question we need to answer to understand. Let me show you an image. So this is the image of global network. You can see all these wires over here, all these lines over here. These are actually cables. So hundreds or thousands of cables are spread across countries. These are laid across the sea beds, sea floors. Remember, these are passing through oceans. Anytime you're sending data, there are huge cables, or I would say lengthy cables, spanned across ocean floors to receive or send information. So these are laid across sea floors to connect islands and continents. These cables are backbone of internet. These are carrying 99%. Remember, 99% of all international telecommunications traffic for personal, business, and government use. All the internet that is happening in the world is only possible because of these cables that are being set up across countries, oceans, and they're connecting the world together. There are huge cables. So these interconnected wires or cables create a worldwide system of computer networks. The global system that we were referring to is created by these particular cables. These cables, they're spread across every continent, every ocean. So they are spanning across that. So we would say who is owning internet now? No one owns the internet, or no one can control who can connect to it. Instead, what's happening over here is thousands of different organizations operate their own network, and they collectively agree on interconnection agreements. So we'll see how these cables are set up, how global network is set up. We understood a small network, right? A home network to set up with basic components. Now we'll see how these global networks, the global internet is set up. So what's happening over here is the undersea cables that we are talking about. Let me just quickly write the bullet points that we studied. Number one, these are hundreds and thousands of cables, not just one, two, but I would say hundreds and thousands. And then they are laid along the seabeds. They're passing through the oceans. The cables cater more than 95% of internet traffic and data transmission across the globe. So remember, this is very important information. Now, whenever you're sending text to someone, remember your text is passing across the ocean somewhere, and the other person is receiving it. So these cables, the undersea internet cables, are called submarine cables. Remember the term submarine cables. We would be using that. Specially modified ships carry these submarine cables on board and slowly lay it down on the seabeds. There is a huge process, a very complex process to do that. So let me show you an example. Let me show you how Google submarine cables are connecting its data center. One particular example. So let me show you that. This is one Google Cloud. They are using a submarine cable to connect its data center. So just pay attention over here. This is North Virginia. This is in US. This is Belgium region. This is in Europe. This could be a France region as well, anything. Now these regions are called landing stations, from where the cable starts or where the cable ends. It could start from here and end it over here. It could start from here and end it over here, vice versa. So these are landing stations where the cable is starting or ending. So see, this is the undersea cable. This is undersea cable passing through the Atlantic Ocean. So now the image depicts Google Cloud. The Google Cloud is connecting its data centers in North Virginia on the left, this one. The Google Cloud is connecting its data center in North Virginia on the left to one of its data centers in Belgium on the right. So this is Belgium on the right. And this is happening through transatlantic submarine cable. So this is Atlantic Ocean, and this cable is passing through this Atlantic Ocean was named transatlantic submarine cable. So let me show you a very beautiful website where we can actually see this cable. We can actually see who owns this cable, who is maintaining this cable, what is the length of this cable, and what are the landing stations. Let me show you a very beautiful site. Let me pull up that screen. Allow me just a moment, guys. Okay. Perfect. Okay. Just give me a yes in the chat if you can see my screen, or if you can see this website. Just give me a yes. Anyone, just type in yes. Perfect. So let's move ahead and let's understand this particular website, why I pulled up this website. Now this website tells the telegeography. What is telegeography? Geography of the telecommunication cables, and these cables are laid across the oceans now. And this particular website is free and regularly updated resource. And this particular website collects and analyzes data on the way the world connects. So what they're doing, the way the world is connecting to each other, this particular website is collecting the data and analyzing it. So let me show you a very beautiful example. The example that we discussed, the North Atlantic cable, the transatlantic submarine cable. So if I just zoom on a little bit, I zoom in a little bit, and I'll just click this particular cable over here. Let me just, okay, this one. Perfect. Now just see this particular cable. I can check who is the owner. Google is the owner. 6,400 kilometer is the cable length. 6,400 kilometer. And from where is it? What are the landing points? One is the France, the one that we discussed, the Belgium one, and the other one is the United States. United States on the left and Europe on the right. European customer on the right. So this is how data is being transferred by one of the Google Center. And if I just go back and zoom out a little bit, you can see the whole network of cables. If you click any one of the other cable, let's see if I click this one, we can see who owns. EXA infrastructure is owning the cable, have multiple landing points. If I click some other one, we can see Microsoft is the owner of this particular cable. What is the length of the cable? 6,605 kilometers, different landing points. This is how internet is traveling across the world. This is how one single message, if a person sends from United States to his friend in, I would say, Spain, this is how that message is being traveled. If a person is sitting over here and wants to connect to this person, this is how the message travels. So this was one beautiful site that I always get fascinated with, and I wanted to show how internet is traveling across the globe. So this is a wonderful site. Whenever you get time to visit the site and play around and check which submarine cables are in your area, which submarine cables are owned by particular companies. You can check by cable, by country as well. If you put any country over here, you can check it over here. You can check it by the name of company. So for instance, if I type Microsoft over here, and if I try to check, does it give me any option? Let me pull up the home page. And if I write, let's say, okay, Meta maybe. So let's connect it to Bahamas. Let's see which cables are connected to Bahamas. So if you want to check through country, these are the cables. If you click on this particular cable, you get the information. Bahamas Telecommunications Company. And these are the landing points where all these cables are being, where the stations are being placed to receive or send information. So this was one beautiful website. So now question comes, why are we still using submarine cables? Let me pull up my whiteboard for that. Perfect. So now question comes, why are we still using submarine cables? The major reason for using submarine cables is they are faster and cheaper than satellites. Why are they faster and cheaper than satellites? Let me show you. Just see this example. I'll zoom in a little bit and just see. You can very well analyze over here. Okay. Yeah. Just on, yeah, perfect. So you can very well see the distance. Okay. Let me just clear this up. Perfect. So the distance over here is 72,000 kilometer. The distance over here is 9,000 kilometer. Let me zoom in a bit. Yeah. So now distance from Tokyo to Los Angeles, if we travel data through satellite, it's 72,000 kilometer. And if we use the submarine cable from Tokyo to Los Angeles, it is only 9,000 kilometer, 1/8 distance. The data needs to travel 1/8 distance. This makes the data to be transferred faster and that reduces cost as well. So this is the reason why we are still using submarine cables. There are many other reasons. The submarine cables use fiber optic technologies and they transmit data with the speed of light. Let me show you a cutaway section of a submarine cable. So submarine cables are using fiber optics. This is one cutaway section of a submarine cable. How these submarine cables are built, different layers. We need not get into those details. We just need to understand these cables are sending and receiving data. And why are we still using them? Because they use fiber optics and transmit data with the speed of light. Now, one question that came to my mind and I started researching about it, these cables are laid in oceans, right? And in oceans, there is aquatic life. There are sharks. What if a shark bites this particular cable? What would happen? I started researching about it. I started finding more articles about it. What happens if a shark bites a particular cable? So then I saw a very interesting video. They literally depict they were recording a shark biting a cable. The cameras were placed under the ocean near the cable, near the submarine cable, and a shark was actually biting this cable. And then many big companies really thought about it and they started working on the protective casing of these cables. After that, the cables were having double protection, galvanized steel, and something like super strong bulletproof material like Kevlars and many other stuff. So that's why this dual protection. The cables are having multiple protective layers. You can see so many protective layers that protect this single fiber optic. This for the protection of this single fiber optic, there are so many different layers. One, two, three, and so many more. So they're using dual protection of galvanized steel and Kevlar-like materials. So this is a very brief overview of the protective layer. There are many other materials. These are some major components that companies started using so that the cables could survive shark bites or the damages through aquatic life. And one of the major reasons why we are still using these cables are that now internet companies, all your tech giants, are beginning to finance and construct their own undersea cables, their own cable sections. Like we saw in the previous slide, that it was the Google who owned that particular transatlantic submarine cable, right from North Virginia to Belgium. So that was one cable owned by Google. Similarly, many other large companies, many tech giants are financing their own cable networks. So these are maintained by large companies. These are four of the major reasons I would say that why we are using submarine cables even till date. So this was what is internet, how internet travels across the globe, and how this entire setup is being established. Moving ahead to the third part of our lecture today, that how we as developers can use internet to make our lives better. So let's see that, because at the end what we want us to be is to be a part of this global internet network and contribute something that would help world or make lives of general public easy. How we can do that? There are numerous things. We as developers are in the core tech industry, and technology, I can assure you, will never go out of style. It would always be in, and you'll always get ample opportunities to work if you have right skills as per the need of current scenarios or current, I would say, innovations and requirements of public. Because if someone wanted to connect with people, a developer created Facebook. Someone wanted to research things, Google created Chrome. Microsoft created so many things. Amazon created your e-commerce website because the developers saw the need that someone wants to buy and shop easily. Someone wants delivery at their doorsteps. So these were all those developers only who saw the need and they contributed something in the tech world. How we as developers can start our journey, there are so many options. Let me discuss few of them. So number one, I would say we can build learning platforms. There are so many learning platforms. We can build, like for instance, this whiteboard only. Some developer built this whiteboard so that we can use it over here. Someone built the Zoom application so that you sitting over there at your place can see this whiteboard in real time. So we can build so many learning platforms like that. Number one, you can build learning platforms. Number two, you can build tools for communication. So many tools are out there. I can show you a picture of it. For example, you can communicate through Facebook, WhatsApp. You can communicate your messages through YouTube videos, Instagram, Skype, your Snapchats, and so much more. These are all communication apps. If you are not building something, you can part of these teams as well. One day or the other, you can part of these teams and contribute so that these apps get better and better. The other example could be entertainment apps. There are so many entertainment apps. Your Prime Video, your YouTube, Amazon Music, Netflix, Disney, HBO Max. You can be a part of research tools and blogs. You can write code where people can publish their blogs. You can be a part of news and media applications, because today our 95% of time is spent on digital media. We are spending our time on phones or computer screens using one app or the other. There's so many news application apps. For instance, BBC News, your Go Shots or AP News, CNN. You can be part of these application building teams, or you can build one of your own as well. There are so many e-commerce websites, Amazon, eBay, Walmart, so much more, Nike, Adidas, or many other big brands also, Reebok. Every big brand has their own application online. You can be part of that. Travel and tourism applications, maps and navigations, and so much more. I'm telling you, the opportunity is endless. You can be part of anything. You can build something, you can innovate something. All you need to understand is that how these things are working under the hood. And we have just touched the surface today. We've just covered the very basic that every developer needs to know. How to set up a network, how what are the components of network, how internet is set up, how internet is working globally, how we as developers can make the world a better place, what are submarine cables, how submarine cables are set up, and so much more. This was one, I would say, the surface layer we have touched for every developer to know. And don't worry, we would be covering so many concepts. So let me show you a very nice video which would depict how all of this is working. We've understood pretty well, pretty much concepts till now. Let me show you a video which is all about the concepts that we've studied so far. Okay. So everyone able to view my screen? Just give me a yes. I'll just show you video. So let me answer one question first. If someone is asking that if the cables are damaged, what is going to happen to data? Will it be saved or it might be lost? I'm telling you, this happens all the time. The cables do get damaged, but there are so many cables laid out there. If one cable gets damaged, the data gets rerouted through another cable. So sometimes you're facing that your browser is working slow, you're lacking something, or your internet is not working that fast. Then this might be the reason that one of the cables that was providing you the network has been damaged, but there are plenty other cables through which the network would be rerouted, through which the data would be rerouted and reach to you. There are plenty cables, and this is what we call a network. There are so many ways that can be connected. Let me show you an example we discussed, I think. Let me pull up that screen. Allow me just one moment, guys. Okay. So just see this example. So everyone able to view my screen, right? So just see this example. For instance, let me just pull up my pen. Yeah. For instance, we say this cable gets damaged, this cable gets damaged. The internet was coming from here, going to here and transmitted to here. Now, the internet would come from here, go to this particular part and transmit it over here. So let me clear this out. So suppose this cable is damaged. Earlier, internet was going from here to here. Now the internet would go from here to here. It would be rerouted. This is one example, a very short example that how network gets rerouted. So there are plenty other rerouting structures being set up by the technical teams and the submarine cable laying ships, so that whenever cable gets damaged, anything happens, the network or data would be rerouted through other pathway. We would be seeing that in upcoming sections when we would be covering client and server model, request response architecture. We would be seeing how the data gets rerouted as well. So this is one of the way the data gets rerouted if anything happens. Okay, let me just pull up the video for us. Okay. Right. Do let me know if you're able to hear the sound.
You know that frustrating.
Everyone able to hear the sound? I'll just play and I'll just play and check.
Frustrating feeling when a message takes more than a few seconds to send? Well,
perfect. I'll just play it from the beginning. It's an amazing video. Just watch it. It's amazing. So let me play it once again. So just sit and enjoy.
You know that frustrating feeling when a message takes more than a few seconds to send? Well, it's hard to imagine today, but before the mid-19th century, sending news across the ocean could take weeks to arrive. Then, thanks to an incredible yet mostly forgotten technological achievement, that gap was shrunk from weeks to seconds, a feat that kicked off the global age of instant communication that we take for granted today. For most of human history, the only way to send a message across a long distance was to have it delivered in person, which was limited by how fast someone could travel. The invention of the electric telegraph in the 1830s sparked a revolution. It allowed messages to be sent across wires as electrical pulses, which could be translated into letters and words. Within a decade of its invention, thousands of miles of telegraph cables were installed between major cities worldwide, linking governments, businesses, individuals, and the press. But there was still an enormous, daunting gap: how to send a signal thousands of miles across the vast Atlantic Ocean, linking Europe and the Americas. In 1854, an ambitious, wealthy young American entrepreneur named Cyrus West Field was presented with a business opportunity to connect a telegraph cable from New York City to Newfoundland, which would shorten the arrival of news by ship from abroad by a day or two. Field pushed the idea even further. What if a line could be extended all the way to Ireland and then on to London, which at the time was the hub of the global economy? Sensing that his project could change the course of history, Field was undaunted by the immense challenge. He raised money from a wide network of investors, including the British and American governments, which also provided the necessary ships for laying the cable in exchange for top priority communication rights on the future telegraph line. Field also recruited some of the top engineers and scientists of his time to develop a cable durable enough to carry a signal thousands of miles across the ocean floor. Laying out the actual cable by steamer ship in the rough waters of the North Atlantic was no easy feat either, and in fact, the first two attempts failed when the cable snapped and sunk on the journey, wasting investor money, dashing hopes, and causing widespread public mockery of the project. Some of the criticisms were philosophical and eerily relevant today. Would instant access to information really make us any happier or better off? Nevertheless, in August 1858, after over a year of disappointments, the two massive cable-laying ships successfully reached their destinations in Newfoundland and Ireland, completing the connection that Field and others had prophesied. Once the line had been tested, an official message of goodwill was exchanged between Queen Victoria and U.S. President James Buchanan. Public celebrations erupted in cities throughout the US and Europe, marking the dawn of a new era of unification between the old world and the new. It's hard to overstate how influential the so-called Electric Union was to the rapidly globalizing world of the 19th century. It meant that everything from stock and commodity prices to a declaration of war or peace could now be shared immediately. It's no surprise that Field's accomplishment was widely heralded at the time as the greatest human achievement in history, and Field himself became an international hero. Although the first cable only functioned for a few months before going dead, it proved that a link was indeed possible. Within a decade, more reliable and sophisticated undersea cables were laid by Field and many others. Throughout the 20th century, cable networks expanded and technology continued to evolve as telephones eventually replaced telegraphs, and then digital data eventually replaced analog signals. While the original transatlantic cable could only transmit a few words per minute at best, today's fiber optic cables deliver hundreds of terabytes of data in just seconds. And there are a lot of them, stretching close to 750,000 miles in total, and more cable was laid in 2018 than in any year in almost 2 decades. Instead of brave entrepreneurs, now most new cables are being laid by the tech giants such as Amazon, Facebook, Google, and Microsoft, which collectively own or lease more than half of the undersea bandwidth. And although it seems that we live in a mostly wireless world, undersea cables still carry 99% of data traffic that crosses the oceans. So the next time you chat with someone on the other side of the world, keep in mind that it all started over 150 years ago by a visionary entrepreneur and his team pulling off what was once called the greatest work that the genius of man ever contemplated.
Amazing, right? So what we use today started 150 years ago. It's so amazing, so amazing. So we have completed understanding internet part. So we have covered what a network is, how internet's set up, and how cables are set up, how it is traveling across the world, and what we as developers can do. So any questions? Now we can move on to question answer round. Any questions? Feel free to put it in chat. I'm more than happy to answer them. Okay, I think okay. So Ahmed is asking, can it be possible without the cables? So Ahmed, the distance between continents is huge, and the connectivity through cables, as we have seen, is seamless. So 99% of data that is being transferred across the internet is with cable. Now, when data transfers from one landing station to the other, at that point of time, after that, different media is being used. Let me pull up that screen and it would be easier for us to understand. Okay, allow me a moment. So just look at this screen and have an overview. So this is one of the cables. I clear this up and just quickly click this in. So this is one of the cables. This is the cable, right? So this is one landing station. So traveling wirelessly from here to here, why companies are not using it? Because this distance is huge and we need some receiver or transmitter in between. The radio waves, if we are using waves, we need some receivers and transmitters for seamless connection. For such a huge, for waves to travel across this distance, we need something in between so that data can be transferred without loss. And setting up these receivers across the ocean beds is not that easy or not that much easy to maintain. So that's why companies are have stick with the cables, because the data can be transferred very seamlessly without any break from here to here. And over here, they have set up the towers, so that now wirelessly data can be transferred, because on ground you can set up towers and maintain them very easily. So that's why across the oceans, we do not have this facility to transfer the data. If we transfer it directly from here to here, the entire data may not reach because they might be lost due to weather conditions, due to so many other factors as well in between. But due to wires, they have protective casing and then so on. And inside there are fiber optics. The transmission is so fast and there is no breakage in the route. There is no breakage in this. That's why this was preferred, and directly through air, it was not possible. So once the signal reaches your landing station A and B, then your these tower A, let's say TA and TB, tower B are established so that wirelessly can be transferred, because now on ground there are multiple towers at after each let's say particular kilometer distance. Companies set up your telecommunication towers as well. So that's why we're using cables and we're not using other media even till date. So any other questions? Okay. Okay, so we are done with the topics for today. Do you want me to give a recap for that, or should we wrap up the session? So Talash, anything you want me to discuss a little bit more? You want me to explain? Okay.
I think everything was very clear. I don't see any explanation needed. It was wonderful, and I don't I don't see anything. But we need a wrapping up and concluding remarks. That's it.
Perfect. So let's, everyone is asking for a recap. Let's quickly recap. Let's clear this up. So what all we discussed today? Let's see. Number one, network, right? I'll quickly discuss what network is. Network, just remember three conditions: group of devices connected together and sharing information. So network has four components: your network devices, your network media, interface, and protocol. Your network devices can be computers, can be printers, servers, mobile phones, gaming consoles, refrigerators, and everything. And your network media can be your LAN cables, wireless connections, radio signals, your light pulses. What is a network interface? The middleman between network media and host, the adapter wherein you put your network cable, wherein you put your LAN cable, that is interface. The interface has two jobs. Number one, to first acts as a middleman between host and cable. I'm just referring to cable for easy understanding. There are other network media. Just for now, I'm saying cable. And number two, it translates the data received from host into right format and transmits through network cable. Last one is protocol. So I'll just write devices, your media, your interface, and last, protocol. Protocol are set of rules between two devices. So protocols have set of rules, right? So these rules are to be followed between two devices so that data can be transferred easily, so that both of them understand each other. That is set of rules. So this was all about network. Moving on, what is internet? Internet. Internet, we discussed three definitions. Number one, huge number of computers connected globally. Number two, now we know devices. So computer are not the only devices. A lot of devices connected together globally is called internet. Mobile phone, camera, your microwave, refrigerator, and whatnot. And third, small network of networks connected together. For instance, network A, network B, network C. So let's say A, B, C, D. So these are connected together. Every network is connected to each other in one way or the other. This whole network of networks is called an internet. This is one part. So now how this is established globally? Number one, what we studied was submarine cables. We call them submarine cables because they are laid on seabeds or sea floors. How they're laid? Through special ships. They have protective casing, which can help the cables protect against aquatic life or shark bites. Now, these are maintained by large companies, Amazon, Google, Facebook. They maintain almost half of the submarine cables, and they're faster and cheaper than satellites. We saw the difference between Tokyo to Los Angeles. If we transmit data through satellite, it was 72,000 kilometers. And if we transmit data through submarine cable, it was 9,000 kilometers. 1/8 distance the submarine cable has to travel. So that's why they're faster and cheaper. And these were submarine cables. Moving ahead, what we discussed, how we saw a beautiful image like Google Cloud of one station in US and one station in Europe, the transatlantic submarine cable that is transferring the data for Google between its two data centers. Then we saw a beautiful website, amazing website, where you can check which cable is owned by which company, what is the length of cable, what are the landing stations, which internet cables are there in your area, which submarine cables are connecting you to other people. Suppose you have a friend in New York, you have a friend in Los Angeles, and if you want to check how you're getting connected with that friend, you can check on that particular website. It's an amazing website. Now, moving ahead, we discussed how we as developers can make use of internet. You can build learning platforms, e-commerce apps. You can be a part of these teams. If you do not want to build it from scratch, you can be a part of this team. You can be a part of news applications, entertainment apps. The options are endless. Even today, if you want to write something digitally, you're creating an application. You can be part of that team. You can create Zoom application, like applications similar to Zoom and whatnot. So many things we can be a part of as developers. So be assured that you are on right track. This skill that you would learn, this would help you be part of a very big aspect of globe that everyone is connected with. Today, even if someone does not know coding, they are using each application, and those applications are created by one of these developers and developers like us. So be assured that you're on right track, right journey. The skills you are learning are going to be helpful at every aspect of your life. And then after that, we saw that amazing video that how everything started, how first telegraph cables were set up, how evolution happened, how phones were then first there were telegraphs, then phones, and then digital media. Initially, when we had to send a message, it was only by person, and it could take months and years from one country to other. Now, within seconds, you can send terabytes of data, and that is only possible through cables. It all started 150 years ago, and many times they failed. But once they succeeded, they understood it is possible to build a link. And I'm telling you, more than 90%, cables were laid down in 2018 itself. In 2018, the number of cables laid down was more than at any point of time. So how this is expanding, we can't even imagine right now. This is expanding at a very fast rate, and we are going to be a part of it. It's an absolutely amazing for us to be a part of this journey. So that's it from my side. Network, internet cables, and everything for today's session. Tomorrow, we would be covering what is web, what are internet services, what is World Wide Web, the www you use at every website. Why are you using it? Who created it? Why was there need to create such technology or such website structure? why everyone adopted, why companies adopted it, why is it in still use. So, and how internet is different from www. We often assume internet and world wide web to be same. They are totally different. We would understand that. So tomorrow our lecture would be focused towards that. Today, network internet cables, do go through these topics in your entirety. Just give half an hour or 45 minutes and just go through what is network, what is internet. Scroll through web browsers and check, read some article, watch some video, go to that website. It would start making things more clear. The more you spend time on it, the more clarity you will get. It was lovely today. I enjoyed it so much with you guys. Any more questions for me? Let me just answer a few questions we have in the chat. So where is main data server located? Someone is asking where. There is no one data server. I'm saying there is no one data. Every company has its data servers, and in many countries. For instance, if we consider Amazon, Amazon is having its data servers across the globe. And we would cover this, that how data servers are constructed and where they are located when we would come to the lecture client server model. So we would cover that. And does this cable has a specific capacity to transfer data? So it depends cable to cable, which particular cable is being used. You might have heard in when you're connecting your LAN cables, for instance, they are Cat5, Cat6, different categories of cables. And according to that categories, the capacity of cable increases or decreases. So it depends what is the requirement in what particular area and what type of cable is being used. So specific capacity depends on that, how data would be transferred and how much to be transferred at what rate. So that's it for today, guys. Any more questions? Thank you so much and have a nice day. Have a wonderful day. Talash, anything from me? Anything for me?